Welcome to the talk about modeling and more. I will show you a little bit about our experiences to build up an EMF model and a model infrastructure around it. Most of the work was done in the context of publicly funded projects. That's the reason for this logo here. So my name is Harald Mackermull. I'm working at Bosch Research, and in the Eclipse community, my roles are committer and project lead of APP4MC, and I'm also in the project management council of the automotive top-level project. I will show you a little bit of the context we have. So the project I'm committer in, and also the modeling technologies we used. It's all related to EMF and modeling projects at Eclipse. Second part is standard usage of EMF, more or less. So what did we do to define the model? What are our experiences in customizing these editors, the behavior of the models, things like that. And then a few extensions we built to be more efficient in different, let's say, search or delete or other operations. Extensions of the editor itself, and especially extensions for visualization, validation, a lot of things like that. And at the end, I will show you some useful tools we are using to have a better understanding of our model, to do documentation, things like that. So to the context, APP4MC is in the center, it's a data model to describe the dynamic aspects of embedded systems, mainly. The model is called AMALTHEA, so you will see this name in some class names later and so on. Central thing is we have to deal with real-life applications. Typically, these models are not built in an editor, but they are generated based on source code analysis, on traces we have to get the timing and other things. And we use it as an exchange format. That was a reason to have, for example, name-based references and a format that is as readable as possible, because it's used by other tools. You see that on the right side. So there are typically performance or timing simulation tools. We can use commercial tools here. Some of the vendors support this format already. And we also have a simple simulation we do ourselves based on System C. So that means we have the typical things like code generation, model transformation, validations for different use cases we have to deal with. So when you start a modeling project, first of all, you see a large number of projects that are in this modeling context at Eclipse. Very successful top-level project. Active community, these are current figures for commits in this area. So it seems to be quite good, but if you look into the details, you see some differences here. So it starts with the web pages. Some of them are outdated. You do not have a good possibility to have an overview what is going on in this project. And you have a very different, let's say, maintenance situation in these tools. So in the end, you have to take a closer look what you want to use there. And in general, independent of this, you have to be aware that every project you're using brings in new dependencies, brings in larger, in the end, a larger platform, additional time to do the builds, and so on. So in our case, we decided to do it in a minimalistic approach. So we use as few dependencies as possible and concentrate on some projects in that area. So first of all, that's obvious. The basis of all modeling projects is EMF. And it's well documented, it's established, it's stable. So I can completely recommend to use that, of course. And it can also be used in a different context. That was important for us. So plain Java is possible. You can initialize all this without an Eclipse workspace. And that gives you a lot of possibilities. So definitely a smiling face here. Second thing we used to define our models was Xcore. This is also developed in the same repository as EMF, so it's consistent, it's well maintained, of course. And it gives you the possibility to have a textual representation of your model definition. For us, important because it's very easy to handle. You can have the typical Git repositories, diffs, go back to older versions. You see all what is relevant here. And you have one source for Ecore model definition, also Gen model, that influences your model, the code generation of your model, so the classes you build, for example. And you can even provide the logic here. So if you have derived methods or operations, you can directly implement it in this same file. And the tooling is also good. I will show you some examples here. So you have code completion, validation, and so on. So again, next one we use is extend. Initially, we used it a lot more. In the end, we reduced it now to specific use cases. So mainly we are using the templates, and we also are using the dev create. That's a possibility to have model transformations in an easy way. So if you have this dev create, that means if you call this method again with the same parameters, you will get the result from the former calls. So it's a map and a cached result in the background. That's also helpful here. So in the end, compact syntax, the extension methods are quite helpful. I will show that in the model builders later. And the template expressions with whitespace handling and so on are still very good to use from my point of view. And what made it easy for us, we used Xcore, and that means the extend libraries are already part of the modeling plugin, so we reused that. So also smiling, but limited to specific use cases. So I would not recommend to use extend for your whole project. And I think that's in line with the developers of extend. Oops, sorry, that was not meant. Then there are a number of other projects we had a look at. We used Sphinx at the beginning to have workspace handling and different customizations, several validation runtime things. I can say we do not use that anymore. The problem with Sphinx was it was not maintained over several years, or almost not maintained. That changed a little bit now, but I still think it's problematic in some aspects that it's very deeply coupled with the Eclipse workspace, and we wanted to be more independent in that case. Model migration, there are several possibilities. Model transformation, there are several possibilities. So I can only say we had a look at that. In the end, we had a lot of specific cases, and it was complicated to have another technology used in. So our decision, but I say that's a we, decided not to use them. That's not a general recommendation. Good. Now some examples for Xcore definitions. As I said, more or less the standard way to do it. So a typical file will look like that. So you have class definitions. You can define your hierarchy here, inheritance. You can have references, containment references, quantities. You can define opposite references here. And of course, you can also use the operations, as I already mentioned. This is extend code here in the body of this derived method or operation here. And you can have type definitions, extended metadata, so all kind of annotations, Gen model annotations, extended metadata. That is from my point of view, a very good possibility and a compact way to describe your domain and your classes you want to use. And a very good example regarding the tooling, from my point of view, is if you do not know the syntax exactly, it's always possible to select something in the editor and open the properties view, and you will see all the relevant attributes of this specific part of your code. And best thing is it's coupled. So if you change some values in this properties view, the text will change accordingly, and you will only see the non-default things in your text. So if you do not know what does it mean, if nothing appears in the properties view, you see it, and if you change it, it will also change in the text. This is true for the main attributes of the classes, but also for annotations. So completely transparent, and it's the best way to deal with it from my point of view. So, next thing you have to do with many model definitions is to restrict the usage, to have some constraints or invariants. And in Extend, this is also quite simple to do. You can have these extended metadata annotations. In that case, I simply define a positive integer. And that means it can be greater than 0 or should be greater than 0. And it automatically triggers a code generation in this standard validator of EMF, so it's completely integrated in your environment. If you do some live validations, for example, or if you have an input check, this will be used, and you can be quite sure that this is always in sync with the standard EMF methods. I listed a few of these possible annotations. There is more, but especially for numbers and strings, it's quite useful. Second possibility that is always mentioned is the invariance. That is a possibility to provide a method that checks the context of one specific class or one specific element. And you only have to provide an operation with these arguments, so you have to have these diagnostic chain and this map of objects, and then it will be triggered every time you change a model element of this class. We decided to group all these in a Java class then, because otherwise the model definition in this Xcore file would be too large, and it's also easier to have it in one place. So it's another class, utility class, that is providing some static methods here. So in the end, I can completely recommend to use Xcore. It contains all aspects, it's easy to handle, it has good editor support, and I also recommend to use these standard methods for validation first before you do any additional validation projects or additional things. And the good integration is the main argument for that. If an editor, the standard editor evolves like it was a few years ago with the live validations, you're in sync and you can already use that. Next part is the standard customization. I think that is well known. So first of all, you can use the GAN model annotations to influence what code is generated. And I have one example here that shows how the properties view can be handled. So you can provide some categories. You see it here that it has some basic elements and some read-only elements. And you can also provide filters. So only if you select these advanced properties, you will see some more complicated parts of the model. It's internal the way how we refer to objects. It's always the name plus type. You can also customize the UI, give more information if you modify this plugin properties file. It's a very easy way to do it. If you override some of the generated things, it will stay. So the generator will not overwrite it anymore, but it will also not delete old values. So it's a good idea from time to time to remove outdated entries. But in general, a very easy way to give some hints to your users, like in that case, that the latency should be entered in terms of computing cycles here. And the standard way to customize a generated code is to overwrite it. And yeah, you simply have to do it. I recommend to use that pattern to add this gen part in the original method, remove this override, and write a second method with generated not. The advantage is that you can reuse the generated code all the time as a fallback, for example, or you can also see if the notifications, if the text changes, if you have to adapt your overwritten method, perhaps. What we then did is we extended the UI with some real extensions in the Edit and Editor plugin. So we provided virtual folders here. This is these gray folders with the number of elements in that collection. Otherwise, standard would be all containments in a flat list below the project, so that was a little bit more useful for us. We have some type info we can show. So this is a task, this is this activity graph, this is the software submodel, something like that. And we also did some extensions regarding how to refer to other elements and how to do links between objects in different files. So these are more extensive additions, and you always have to decide what is necessary for your project to do it. So in our case, it's if we open one of these files in a folder, you see all the green dots here, all the other models that are relevant are also loaded. We have some feedback, these brownish or sepia colored things are outdated model versions. And if you open it, you see also why it is not included in that. It has an annotation of the former version of the model. And this setup was okay for us. It has its limitations. You should not add files to this folder while editing it, things like that. That is shown here with this construction sign, something like that. But for us, it was good because we can have drag and drop between different files. We do not have to add links to files we want to refer to. And we can also combine different files. If the names are okay, the references will be established at start time. So, lessons learned again. We used as much as possible the standard EMF edit customizations. The simple things is to replace icons, to replace labels, and to annotate the model elements according to what you want to get. And we always try to reuse existing label providers, things that are already available. So you should not throw away things that can be reused in a context, of course. We now had the problem a few years ago, if you have a large model and a lot of references in it, we had to do some optimizations here. So the requirement was to have a fast search and also delete of models, and we wanted to have transient backpointers. So the opposite references are limited to, you have to provide it on both sides. But we wanted to be able, if there is a link to an object, we wanted to use it in the opposite direction without storing it in the model definition. So just to illustrate that, the black ones are the containment references. You have some links to this. And of course, if you now want to delete this object, you have to delete also the sub-elements in the containment tree, and you have to remove all the links to these objects because you don't want to have these dangling pointers here. In the end, we came up with an AMALTHEA index with the help of Ed Merckx, to be honest. So this is a class that provides the helper methods. The idea is quite simple. It's built on demand. If we use this index the first time, we use the object that you want to have the references for. We try to get the top level element. So top level is the root of the object tree. Next possibility is the resource, and then the resource set that contains the resources. And we establish an adapter at that level. And this adapter contains some maps that are used for these references. We have two maps. One is object to all, one is name to all objects of that name. And the second one is regarding which objects and which features are referring to this object. This makes it quite fast if you want to load models, for example, and you want to deal with these name-based references also. In the model definition, then it looks like this. So some documentation to make it clear for the users that this is a derived method, that it's immutable, and then we simply call this AMALTHEA index, get inverse references, and we provide the feature definitions to show which one we are interested in. Next one was we have several tools that rely on our data model, but these tools have different information needs and requirements. So we wanted to be sure that there is a possibility to do some validations that is use case specific. So if you want to, for example, simulate it with a tool from Timing Architects, you can use the checks for Timing Architects to ensure that all the relevant information is already there in the model and is consistent before you export it and use it in another tool. So the idea was we tried to build a flexible possibility here. We used Java annotations to describe profiles that can be hierarchical, and each profile can contain single validations. We used OSGI annotations in combination with the Java annotations. And to show you how this looks like, this is the code of one of these possibilities. So the first one is the profile here that contains a number of validations, simply refer to the class that is involved. And we define the validation for a specific object. We have to provide the feature we are interested in. So it's here this hardware connection we want to use. And you can now see this is the complete code for a validation you have to do. We provided a framework that reads the annotations, and then you have the possibility. The component annotation of OSGI means it appears here at a top level. The name will be available. Here you can check what you want to, you can provide a check mark what you want to check. And of course, the information that is provided here is also reflected. So you have a quite easy integration, and that was already used because the validations for the specific tools were provided by the tool vendors and not by us. So it proves to be simple enough to do it without any deep knowledge of validation, how we iterate over the models, and so on. Then we did some editor extensions. I have to hurry up a little bit. So we tried to have custom visualizations and some editor actions. Same idea. We have these component annotations of OSGI, and this is the complete code of a very simple visualization that only shows the qualified name, of course. So you get the composite, and you have complete freedom what you want to use for this visualization. So the object you want to show and the composite, and then you can work on that. There is a standard view, and the provided properties you have here will show up in a list of possible visualizations for this type of object. And Just to give you a few examples, we used some plant UML visualizations for this hardware structure. Software structure was plain graph with some JavaFX dependencies. We used the charts of JavaFX to provide some diagrams regarding these probability density distributions, and also, of course, simple SVT or nut table types that can be used here. Second possibility was to provide custom actions on specific models. So same idea, we have a component annotation and the name provides the hierarchy of this menu here and also the additional info you see if you hover over it. And in the end, you only have to deal with the manipulation of the object. The framework gives you the rest so that you can, for example, use this change recorder that's used in the background. You can undo the action, things like that. So it's very easy to extend the model here and to have custom-specific modification of small parts of the model. You should not do this for a whole transformation, of course. Model migration, I already said we did not use the standard way, so requirements was to have migration to newer models because our customers had a lot of old models already. If the meta model evolves, we have to update the models, and it should be possible to do it in a batch way to go over several folders and transform all this, so it should not be coupled with the Eclipse workspace, of course. In the end, we decided to do that on XML DOM level, so it's not EMF in that case. We provided a step-by-step migration, so always to the next version of the model. And a typical snippet looks like that. So we used these XPath possibilities of JDOM2. So that means you have to know where your elements appear in your model hierarchy. So you have to know that there is a software submodel and the runnables are in a collection, and then you have these conditions, for example, you want to modify. But it's quite fast if you do it that way, and you can manipulate on XML level. But you have to know the model structure in detail, and that's the reason why I also say we have some useful tools here. So we use it for documentation, but also to understand the model. So one thing we showed a few years ago in the modeling symposium is this EMF viewer. So we have a meta model explorer. Every EMF model that is available in your workspace will appear in this list. Simply select it and you will get all the classes that are involved, and you can initiate some diagram generation based on this input. And examples are you can show the hierarchy, you can show the context of an object with all its relationships, and you can also see where a class is used in this model. That was especially helpful for the migration part. What we also used for documentation purposes was the diagram editor. That is always a good possibility. We had Xcore, so we transformed it to an Ecore and Gen model and started a modeling project, copied in these model files, and then you can work on that and create specific views of what you are interested in for your documentation. We did not model on that level. We used it read-only and only showed elements here. And now last thing, really last thing, we wanted to be able to have good possibilities to create small model snippets especially for our unit tests. It was inspired by Groovy, where you can have nested maps like that. There was an interesting talk of Sven Eftinger years ago, and I used that as a background. So we created some model builders in Java. It's always the same pattern. You call this with a container and an initializer. So you will create a new object, will link it to its container, and then do the initialization. And We use that with Extend 2 because we can avoid some boilerplate code, and it's a really nice nested syntax I will show you here. So containment is expressed by nesting. So you see here AMALTHEA is the top level element, then you have some software model, some labels in it. It can be combined with objects that are generated in other parts or other methods. You simply can refer to elements around you. You can have factory methods that makes it easier for you to create model parts that appear over and over again. And of course, you can have cross-references. So we have a simple map behind. We register some of these elements that is in that part, and we refer to them here. So that makes it easy to have this as part of your unit tests. And of course, it's more easy to have it as a model, as a code snippet compared to an XMI file, because XMI files can be old. You will not get any notifications in your IDE. But if something changes in the attributes, your methods will not work anymore, and you will see the red markers immediately. So typical tests will look like that. We will have one part where the model is created, do some tests, and check if the results are as expected. So as a summary, we decided to try to have minimal number of dependencies of our core components. We relied on EMF only as far as possible, and we built some frameworks to make the complicated parts easier. That had several advantages for us because it's now easy to reuse the components. We already did that in command line tools or in web services. So we can load the models, validate them, migrate them on that level. And of course, contribution is made as easy as possible so that you have a limited number of technologies, limited number of additional languages. So if someone knows Java and the examples with the annotations, it's quite simple to extend this. I provided links to all the different parts here, and therefore, thank you for your attention, and I'm open for questions. Any questions? Okay, then. Yeah.
You mentioned that you don't recommend to use Extend in new or our own projects. Can you elaborate on that?
Just in the sense, if you use Extend in your whole project or in a larger code base, it's more complicated, for example, to do refactoring and all the things that Java provides. So Extend was a very good language when it was started, but also Java evolved over time. So I would recommend to use it for these specific purposes, like these nested syntax that is quite easy to use, extension methods, and especially the templates. We used it for code generation here. Yeah.
Is there a reason why you prefer extension methods over extending the interfaces, for example, the classes that are extended by the extension methods? Because in the end, you add some API like on another place, but then I also want to add like so important from some of the Java developers when they elaborate a little bit about what they think about extension methods, and they consider to add it to Java, but in the end decided to not, because you add some API to the class, but it's defined somewhere else.
So I can say we only used it in this builder part currently, and again, you do not have to use the. It's a static method, of course, that is mixed in. You do not have to have this reference all the time. You can provide some extensions at the beginning and then simply use it, but it was only for readability and only in this limited use case for me. Okay, then Thank you all, and don't forget to vote.